Hi everyone, so in today's lesson we're just going to spend a bit of time recapping what we did yesterday in terms of our electrolysis and then looking a wee bit more detail about the half equations that we started at. So you'll remember that electrolysis is all to do with these types of compounds. They're all ionic compounds, and we've got two ions. We've got our positive ions, which are our cations, and we've got our negative ions, which are our anions. And you remember from your work with Unit 1 and our bonding that metals form positive ions because they lose their outer electron when they become an ion. So think about sodium and potassium are in group 1, so they would have lost their outer electron to become a 1 plus charge. So in this case we've got Na plus, or you would have had K plus. Calcium and magnesium are on group 2, they would have become a 2 plus charge ion. And our non-metals then, they form the negative ions. So think about, so chlorine's in group 7, so it would have gained 1 electron to become to have a full outer shell. It would have been the Cl minus. Oxygen, for example, is in group 6, so it would have gained 2 electrons and become O2 minus. So electrolysis, this is our definition of electrolysis. It's the breaking apart a compound by electricity. But what we learned yesterday then, that it was the breaking apart of an ionic compound by electricity, and the ionic compound had to either be molten or dissolved in water for this to work. Now, hopefully you can remember why it had to be either molten or dissolved in water. So remember, an ionic compound, when it's a solid, will not conduct electricity, but when it's molten or dissolved in water, it will conduct electricity because the ions are free to move. So if you aren't sure about this, if you have a look back through your Unit 1 work when we did bonding, just to refresh your memory about the properties of ionic compounds. So we want the ions to be able to move and to conduct the electricity, and that's how they separate out. So here's just a little summary of the key terms that we've been looking at. So we have our electrolysis setup, which is a battery or a cell. Sometimes it have a lamp or a bulb in the circuit to show that it's conducting electricity. Then we've got our electrodes. Okay, now the most common thing that the electrodes are made from would be graphite. And yesterday we talked about 2 reasons why graphite would be used for the electrodes. Oh, I spelled that wrong. So graphite has a high melting point because it's a giant covalent structure, but it also conducts electricity. So it wouldn't contain ions because it's a giant covalent structure, but it will conduct electricity, and it's not going to melt in the high temperatures that you'd have your molten compound at. So we've got our positive electrode and our negative electrode. So yesterday we learned that the negative electrode was called the cathode, and it's because the cations, remember, are positive and they go to the negative electrode. So you can either remember it that way, or you can remember the acronym about positive anode, negative is cathode, the panic acronym that's in your booklet that you can have a wee look at if that's something to help you remember. And then the electrolyte was the liquid that the electricity passed through, or the ionic liquid. It could be either molten or it could be a solution, an ionic solution. So hopefully then you remember each of these words that are on the board at the minute, or on the screen at the minute. So yesterday we looked at our example was lead bromide, and in your booklet it said that the formula for lead bromide was PbBr2. So we talked about how that was split into the Pb2 plus ion, and we would have 2 Br minus ions. So when the electricity went or was turned on, the Pb2 plus ions moved towards the cathode, and we got molten lead at the bottom. So it's really written here. So we got molten lead, and what happened there was that the lead, the Pb2 plus, accepted electrons from the electrode and was turned back into the element, which was just Pb. And at the other side then we've got our anions, which are going towards the anode, and because the group 7 elements are diatomic elements, when they join, 2 atoms join together to make the element, so we get 2 bromide ions going here. They each lose an electron and they get turned into Br2, and we got Br2 gas given off. And then because bromine is coloured, then you would see one of your observations would be a brown gas given off, and you would also see a liquid metal or molten metal here. Okay, so hopefully that's refreshed what we got to yesterday. We then talked about a half equation. So this is a diagram, just sort of a general diagram showing what happens with the half equations. So half equations show what happens at each electron, and they involve either gaining or losing electrons. And I introduced yesterday this acronym here, which was OILRIG, which is oxidation is loss, reduction is gain when it's talking about electrons. So when our cations go to our cathode, you'll see this is a bit like the animation I showed you yesterday where they have the little circle which represent the electron. So here the sodium ions gain an electron, will turn back into sodium metal. So it'll be Na plus E minus goes to Na as metal. And then here you have your anions going to your anode, and then they donate the electron when they get here. So because this is a diatomic element, you'll have 2Cl minus goes to Cl2 plus 2E minus. So that shows that each chloride ion loses, that's a plus, sorry, loses 1 electron. So you end up with a chlorine gas plus 2 electrons and 1 electron coming from each of the chloride ions. So let's have a reminder about our lead bromide then. So this is the work that we were doing yesterday, or it was covered in the video yesterday. I just want to recap it. So this is at the cathode. So we've got our cations going to our cathode, and our half equation is going to be an ion turning into an element. So we've got our Pb2 plus, and it's going to turn into Pb. So let's think about how does it turn into it. So at the minute we've got a 2 plus charge, it's already lost 2 electrons, so it needs to gain 2 electrons in order to turn back into the lead. Now if you're really not sure, think about, remember we've learned about balancing equations before, so this equation needs to be balanced for charge here as well as number. So on this side of the arrow we've got a 0 charge because the Pb, the element, has a 0 charge. So if we have a 2 plus charge here, we're going to have a 2 minus charge, so that the left hand side also has an overall charge of 0. So if you're really not sure, you can't remember, you can't think which one it is, have a look at the charges because they need to balance out. So if we think about our oil rig, what is happening is that the Pb2 plus is gaining electrons. So we say that Pb2 plus is reduced, it gains the electrons. Okay, then at our anode, so we've got our anions, which are Br minus, coming over here, and they donate their electrons. So it's like they have an extra electron already. They've gained that electron when they formed an ion. So when they want to go back to an element, they need to get rid of that electron. So they're going to Br2 plus E minus. Now, because this forms a Br2, remember it's a diatomic element, we need to have 2 Br minus ions to balance out the Br2, so we've got the same number of bromines. But here now we've got a 2 minus charge on this side because we've got 2 of the Br minuses, and each of those loses an electron, so we have a 2 E minus on this side. So again, if we're balancing our equation, on the left hand side we've got an overall charge of minus 2 or 2 minus. So on the right hand side we also need to have an overall charge of minus 2, just check that it's balanced. And in this case what's happening is that the Br minus is oxidized because it's losing an electron. Okay, hopefully you're happy with that, and you've had a look at the questions there. Here's an example that we didn't look at, and this is at the bottom of page 5 in your booklet. So we didn't do this yesterday, so I just wanted to go through it with you today. So it's asking us to look at what's happening, or it shows us an example with molten lithium chloride. So the formula is LiCl. So lithium is in group 1, so it forms an Li plus ion, and chlorine is in group 7, so it's a Cl minus ion. So these are the ions that we've got in the electrolyte in here. Okay, so when the electricity is flowing, so this, instead of just being a circle, should just be a bulb. So the switch here is closed and the electricity is flowing. So when it's flowing, then our ions move to the respective electrodes. So at our cathode then, we're going to have our cations. So we're going to have our lithium ion is going to come to our cathode, and it's going to turn into lithium as a metal. So our negative electrode, they've got lots of electrons. So the lithium is going to gain an electron. So lithium ion is going to gain an electron to form lithium as an element. So remember, our ion goes to our element. Okay, so hopefully that at the bottom of page 5 says at the cathode lithium metal is formed. Lithium ions gain one electron to form lithium atoms. Write the ionic equation for this process. So this is an ionic equation that's happening at the cathode. Okay, so that's the bottom of page 5. Then at the top of page 6, it asks you to write down the ionic equation for what's happening at the anode. So the anode here is a wee bit more tricky because it's a bit like the last one where we've got a diatomic element. So we've got our chloride ions are going to come to our anode and they're going to form chlorine gas, a diatomic element. So because we're going to have a Cl2 formed, we need to have 2 Cl minuses to start with. And then each chloride ion is going to lose an electron to form an atom or form an element. So we're going to end up having 2 electrons on the right hand side. So let's just check that we've got this balanced for numbers. So we've got 2 chlorines, and check we've got it balanced for charge. So on this side of the equation, we've got 2 minus charges, and on this side we've got 2 minus charges. So it says here on page 6, it says at the anode green chlorine gas is observed. So this is going to be a gas and it's going to be green because it's chlorine gas. Remember learning about that in year 10. Chloride ions are attracted to the anode. So the chloride ions are negative and the anode is positive. So they're attracted to the anode. Each chloride ion loses 1 electron to become a chlorine atom. 2 chlorine atoms then combine to form chlorine gas. And write the ionic equation for the process. So this is the ionic equation that's happening at the anode that you can fill in top of page 6. So yesterday, hopefully you were able to answer the questions on page 6. So today I want to just talk about these half equations, these ionic equations at the anodes and cathodes, and we're going to fill in page 7. So I'm going to do the first one, or maybe 2 for you. So the first one, we've got potassium chloride, so it's going to be K plus and Cl minus. Okay, I want you to remember that the cathode is negative and the anode is positive. So our cations go to our cathode. I remember we're going from an ion to an element. So how the ion does this, so with the metal, the potassium ion gains an electron to form a potassium atom. Okay, that's our and we will see a potassium metal formed. So it says here, write ionic equations for the reactions happening at the cathode and the anode and the following compounds. In each case, state what you would see during the reaction. So what we'll see is potassium metal is formed here. And then at the anode, we've got chlorine, so we've got Cl minus, and it's going to form Cl2. So remember, we've just done this. We're going to need 2 Cl minuses because we're going to have chlorine gas. So this is going to be a gas, and we're going to see green gas produced because it's chlorine. And then when the chloride ions come to the anode, they each lose an electron to become an element. So we've got an ion going to an element. So each chlorine ion loses 1 electron, so overall there's 2 electrons lost. So this is our ionic equation for what's happening at the anode for this one. Okay, for part B, I want you to try this yourself. Pause the video now and see if you can do it, and then I'm going to fill in the answer. So for zinc and bromine, we've got a zinc 2+ ion, and we've got a Br minus and Br minus. So we've got 2 bromide ions. So remember, the cathode is negative, the anode is positive. So at the cathode, we're going to have the zinc ions, and they're going to turn into a zinc metal. So we're going to see zinc metal formed, which is like a silvery colored metal. Okay, how it's going to do that, so zinc has a 2+ charge, so it needs to gain 2 electrons to form an element, to go from an ion to an element. So we've got zinc 2+ plus 2 minus goes to Zn, or zinc. And at the anode then, we've got Br minus, and it's going to form Br2. Now because the temperatures, because it's molten zinc bromide, we're going to have a gas, and bromine gas is a brown gas that we will see. So we need to have, if there's Br2, we need to have 2 Br minus, and then to go from the ion to the element, the bromine ions need to lose an electron, and they each lose 1 electron, so we have 2 electrons being lost altogether. So the 2 ionic equations, so for the cathode it's this one, and for the anode it's this one. Hopefully you got that right. So I want you to try these other 3 now and see how you get on. Write down the ionic equation for each one, and then I will see you at 1 o'clock and we'll go over the answers.